Dear student, in today's class, we have to discuss different bitwise operator and different uses of bitwise operators. In previous classes, we have already discussed different arithmetic operators, which include unary operator, binary operator, ternary operator. Also, we discuss relational and logical operators. Today, one of the important operator we have to discuss, that is bitwise operator. Why the name is bitwise operator? Because as we know, computer memory is made up of intersection of rows and column forming number of cells and sectors, and in each cell the values are stored in the form of ones and zeros. In the memory there might be the thousands of rows and columns intersection or more than of that. This memory cell may be identified as 1, 2, 3, but value will be stored in the form of ones and zeros. Why the name is bitwise operator? As the name is bitwise operator, the operator through which we can operate on each individual bits of memory, hence it is known as your bitwise operator. Different bitwise operator we have to discuss in this session include ones complement, which is represented by tilde symbol, bitwiser, which is represented by pipeline, bitwisand, which is represented by single ampersand, exclusiver, which is represented by exponent symbol, left shift operator, which is represented by double less than, right shift operator, which is represented by double greater than. These six operators to be discussed in today's session. We try to discuss and clarifying the use of ones complement operator. Ones complement operator is a unary operator. Why it is a unary operator? The operator which require one operand to fulfill its job is known as your unary operator, and hence as ones complement operator required one operand, hence it is known as your unary operator. And what is the evaluation process of this ones complement? It returns the reverse value of entire bit pattern. Reverse value means the place will be 1, that will be 0, and the 0 place will be the 1, means 1 becomes 0, 0 becomes 1, that is known as your complement value. We try to understand you, clarify you how this bitwise ones complement operator works. Suppose I take one of the integer variable x whose value is 12. How you have to understand the computer takes automatically, but we try to understand how this one's complement works in memory. Suppose this is 12 is a decimal value. How you have to find the binary value? We divide it by 2 and the remainders will be taken into consideration. 2 6 is 12, remainder is 0. 2 3 is 6, remainder is 0. 2 1 is 2, remainder is 1. And when you write, we will be writing from bottom to top, and hence the value will be 1100. As you must know that, knowing that one integer takes 2 bytes of memory, 1 byte is 8 bit, 2 byte means 16 bit, means 16 cells will take. This is the 16 cell, if you can count. In 16 cell from the right side 1100 will store 1100. Rest 12 bits never left blank, it will be filled by leading zeros. Again I am repeating, 1100 will occupy right side 1100 4 bits. Remaining 12 bits will be filled by 0. This is the value of x. If I calculate the complement of x, then the result will be how many cells? 0. That will be converted into 1, and the 1 will be converted into 0. Means 12 0 will be converted into 12 ones. 2 1 will be converted into 0 0. Another 2 0 will be converted into 1 1. This is the complement value of x. If I will calculate the value, because I run the program, computer will result the value. How you understand the value is right? Then our process is converting binary value to the decimal value. For converting binary value to decimal value, the formula is used 1 into 2 to the power n minus 1, which means in which place 1 occurs, some value will result. In which place 0 occurs, no value will result, because 0 into something is 0. If I count down from right to left, the utmost left position, this one is 16. Nth position is 16, means 16 minus 1 is 15. Then the next position is this one. If I count from right to left, this position is 15. 15 minus 1 means 15 is nth position, 15 minus 1 is 14. Like this we will go till the first location. If I count 1 nth position is 1, 1 minus 1 is 0. If I calculate and find the sum of all value, it will be giving a large value, and that value may be anything else. So you will be calculating, you will be getting the result. If you run the program, that result will be carried, and if you manually calculate, same result will be carried. So that verification will be made, the calculation manually and the computer result is same. So how we have to run it? Suppose I take int x equal to 12. If I write printf percentile u complement of x, then it will result this value. Exact value is this. If you calculate in this way, in this formula, if instead of a percentile u, if you give percentile d, a negative value will be carried. Negative value represent the garbage value, because one integer having a range, in later part we will discuss. Then if this is not fit within the range, the garbage value will be carried. Why I have taken percentile u? Percentile u for unsigned integer, because integer is classified into signed integer, unsigned integer, long unsigned integer. Only you remember that much. In comparison to integer, unsigned integer takes the maximum value, store maximum range of value, and for unsigned integer, like percentile d, unsigned integer, the formatted string is used as a percentile u, and hence if percentile u complement of x we display, the result will be exactly like this. Negative value will not come, and that negative value suggests that the value is garbage, means the value is not adequate with that formatted string or respective variable, and hence we have to take the higher data type and higher format specifier. If I run the program, I will get the result this one. I have also run this program and given you the output just like this. I will run in later part. If this program will be run, x equal to 12 and percentile u complement of x, the result will be here. As previously we run in the online compiler, in the same way you have to run in online compiler. If I take percentile d complement of x, then the result will be minus 13. Minus 13 is the garbage value. In both the way I have displayed and run in the form of percentile u as unsigned integer, right value will display. If I give percentile d, the normal for the integer value, then the garbage will come, because that value will not exist within this range. Now we complete the use of ones complement operator. I think the concept of bitwise operator and ones complement operator is understandable to you. Now we try to run it in the online compiler. Just I have to move to online compiler. First of all, I have to connect with my network. If the network will not connected, then online compiler will not run or open. I try to connect with online compiler. Just wait please. If online compiler will not, yes, now online compiler will work, because net connection established. Now online compiler comes in. See, I am writing x12, then complement of x, the result will be what? Minus 13. If I make it percentile u, then the result will be exact what we have discussed and shown. If I give percentile u, just wait please. Now the result is carried. In this way we can run any program. Then in the today's class we discuss the use of unary operator, we discuss how it works in memory, we run the program, we have provided the output. Now I think you understand this lesson, and if you are having make any comment, kindly make the comment, or having any doubt in the previous lessons, kindly make the comment. In the next class we have to discuss the bitwise operator, which include or, and XOR. I think this is beneficial for you. Having any doubt or you understand, please make the comment. If you those are not subscribed our channel, kindly subscribe the channel, and always we try our best to provide the best lessons and the problems and with solution for your requirement purposes. Thank you. See you in the next class.